All right, welcome back everybody to another thrilling installment of implicit differentiation. Here, there's nothing new to learn. We're just going to do a quick review of when we would use implicit differentiation and then do a few quick examples. So again, to stress this again, we use implicit differentiation when the y is not by itself. Okay, so the idea is to take the derivative, and wherever we come across a y, we're going to differentiate that term as normal, but then we're going to write a dy dx because we know y represents a function, and that dy dx is kind of our use of the chain rule there. And so then once we've differentiated all of the terms, we're going to ultimately solve for dy dx. So here we go. Find dy dx for the following function. Again, I note that y is not by itself, so I know I need to use implicit differentiation. Now in my first term here, I've got some product rule. So I'm going to do 2x squared times the derivative of y, which is just going to be our dy dx, plus y times the derivative of 2x squared, which is just 4x. Now I'm going to differentiate my 3y terms, so I have plus 3, and then I have dy dx, and that's going to be equal to 0 because the derivative of that constant 16 is just 0. So now all of my dy dx terms I'm going to keep on the left-hand side of my equation, and anything that's left over will go to the right. So I have 2x squared dy dx plus 3 dy dx is equal to, and then this term I'm going to subtract to move it over, so I have a negative 4xy. So now I'm going to factor that dy dx out of both of my terms, and I'll have a 2x squared plus 3, and that's equal to my negative 4xy. So then my last step, I'm just going to divide, and my derivative is negative 4xy all over 2x squared plus 3. And there we have our derivative. So now we're going to do a quick problem where we're going to find the second derivative, and we know that just involves taking the first derivative, and once we take that second derivative, we're going to be substituting the first derivative back in. So here we go. Implicit tells me this is 6y dy dx plus I'm going to have my 6x term, and that's equal to 0. So this is going to work out nice and give me a pretty straightforward derivative. So I get 6y dy dx equals a negative 6x. So my first derivative, dy dx, is going to be a negative 6x over 6y, or just negative x over y. So now I'm going to take my second derivative. I'm going to use quotient rule here. Okay, so I'm going to have y times a negative 1 minus a negative x times dy dx all over y squared. And so now, along with doing some simplification, negative y plus x, I'm also going to substitute my negative x over y for dy dx. Again, I'm taking this value, which we know is our derivative, and plugging it in for dy dx. And that's still all over y squared. So now, just to get rid of this fraction, I'm going to multiply by y on top and bottom. I'm going to distribute that y so that I get a negative y squared minus, my y's are going to cancel here, so I have an x times a negative x, so minus x squared all over y cubed. And that'll be my second derivative. So tomorrow we'll have one more day with practicing implicit differentiation before we move on to the next topic.